Welcome back. Today we are going to look at features of the graphs of exponential and log functions. We're going to walk through some of those and let's see how we do. What are the features of the function f of x equals -2 times 1/3 raised to the power of x plus 5 graphed below? This is a pretty monstrous looking question, but there are only 5 of these on this entire assignment. So let's take a look at each piece of this. The function here is a logarithmic or an exponential function. Now, the way we can answer that question is, do we have an x in an exponent here? Conveniently, we do. But the other way would be if we had log of x in some form or fashion. So clearly this is an exponential because x is in the exponent. With a blank asymptote, horizontal or vertical. The question is, are we able to use any domain or are we able to use any range? It looks like it's going to be flatlining horizontally to x equals 5 here. Right here, it doesn't, to y equals 5. Scratch that, yes. Y equals 5. It appears that it approaches it very closely, but is never actually going to make it to that point. So exponential functions are going to have horizontal asymptotes because you can put in any x you want into the expression, but you can't go above or below a certain point. Logarithmic equations are going to be a little different for reasons that you'll see once we get to one. The asymptote is, remember, a horizontal asymptote. Despite x being the horizontal axis, if you fix an x value, you'll have a vertical line. So you want a horizontal asymptote to have a y equals, because that means all of the x's for which y equals, and we said earlier, 5. Because it's never going to cross above y equals 5 in that. The range of this function is, got a lot of options here. Remember, this is the y values we're allowed to have. And it looks like we can go down as far as we want, so it's going to have a negative infinity in there. And it looks like we can go up as far as we want until we get to 5. So negative infinity to 5. And it is blank on its domain of blank. It appears to be decreasing because it goes really far down and not very far up. However, as an exponential function here, since when we move to the right, we get less negative and more positive, we have to say it's increasing. Decreasing would be if it were pointing up as it goes to the left and pointing down or flatlining towards the right. But let's go ahead and say its domain is all the values that you can put an x in there, which that's actually going to be everything. Despite the fact that it appears, graphically speaking, to go down towards x equals -2, you can actually put any value of x in there. The reason it has to do that is because as you put them further and further to the left, this function's behavior gets more and more extreme. So the end behavior on the left side is as x approaches negative infinity, y approaches negative infinity, because it's going really, really, really far down as you move left. And the end behavior on the right side is as x approaches infinity, because remember, it has a horizontal asymptote, meaning the x can move on forever. Y approaches 5. That's going to be that number where y is going to here. So that was a really long problem, a little long-winded, but once you know what all this stuff means, it's not too hard to plug in our answer. Let's go ahead and try another one. Perfect. So the first question is very obvious because if it's exponential, it has an x in the exponent. And if it's logarithmic, it'll have the word log or occasionally ln, which means natural log. So it is a logarithmic function with a vertical or horizontal. It's going to be, if you look carefully here, the green line representing the function doesn't actually stop and T-bone into the y-axis. It joins in the y-axis and approaches it. So a logarithmic function, by the way, is always going to have a vertical asymptote, and an exponential function will always have a horizontal asymptote. So the asymptote here is, again, this one's going to be x equals because it is vertical, because you fix an x value and all the y values are vertical. X equals 0 because it looks like it's almost the y-axis. The range of this function is actually going to be everything, because as you move closer and closer to x equals 0 from the right, you're going to go incredibly far upwards. And as you move further and further to the right towards infinity, you're actually going to keep on going down forever and never approach anything. You're just going to go really, really slowly. So it is decreasing. You can kind of see that one a little more easily because it's kind of slanting downwards like a hill on its domain of everything to the right of the y-axis, which is 0, infinity. The end behavior on the left side is x approaches 0 from the right. We've said that a couple of times. Y approaches infinity because it keeps on going up and it never gets to 0. On the right side, x approaches infinity because it's just moving on. And y approaches negative infinity because it just keeps on going down forever. Let's go ahead and try the next one. What are the features of this function graphed below? Now, note, we've got the word log in this one, so it's going to be logarithmic, which means we know it has a vertical asymptote and an x equals asymptote. So those three things are always going to go together. If you have an exponential function, it's always going to be horizontal asymptote of y equals something. But we're going to find out what it is. We could do it with the equation itself by saying the inside of a log argument can never be 0 or below. So that has to be positive. So x has to be at least 2 at any given moment. So it's going to be x equals 2 is the asymptote. And if we look on the graph, we're going to find that that's exactly the case. The range of this function is actually everything because the y values go down forever when you approach 2, and they go up forever when you approach infinity. It is increasing because you see it kind of climbing and making a name for itself here on its domain of everything to the right of 2. So 2, infinity. The end behavior on the left side is as x approaches 2 from the right, meaning as we're getting closer and closer to 2 from things slightly greater than 2, y is going to go down to negative infinity. And as x approaches infinity, because it can expand outwards forever, y approaches infinity, because they're just going to keep on going forwards and upwards. So we're going to submit our answer, and boom, we nailed it. Let's go to new problem. Since we just did a couple of log problems, I'm going to go to new problem again. This, note that it doesn't say the word log or even ln. It's got an x in the exponent. So let's go ahead and fill out the first three things because we know it's exponential, meaning it has a horizontal asymptote of y equals something. So that we know just from the fact that there's an x up here and there's no log. So for an exponential, if we just have the function, then we can know that for the same reason that the inside of a log can never be less than 0, an exponential can never evaluate to 0 or less, even if you've got a negative number on, well, mistaken. If you have a negative exponent, is what I meant to say, you can send the exponent itself to negative infinity and you're still never going to get below 0. So let's go ahead and plot the fact that this means, by the way, that if it is an exponential term plus some constant, in our case that constant is -4, we're never going to get below that constant. So y equals -4 is going to be the asymptote here. The range of this function is everything above that, so -4 to infinity. And it is increasing. We can tell a little bit more easily with this exponential than some of the others on its domain of everything. You can plug anything into an exponential. The end behavior on the left side is x goes to -infinity because we can plug anything into it. And y approaches -4. So it's going down, 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 down until it gets to -4, but then it just kind of flatlines. But it's still going down towards it. And the end behavior on the right side is x goes to infinity, y goes to infinity. So I'm going to submit this answer, and I'm going to leave you with the rest of the problems. Raise your hand and let me know if you have any questions, and I will get to you when I can. Have a good one, y'all.